Okay, so we're going to be learning how to take the volume of a prism or a cylinder, and we just need to remember that a prism can have any kind of polygon as its base. So it could have a rectangle, it could have a square, a triangle, a hexagon, any kind of polygon. So if we look at this solid here, and let me zoom in on that a little bit. This solid is what you would call a rectangular prism, and because it has a rectangular base, right? And so to find the volume of it, the formula that we use is capital B, which stands for the area of the base. Times the H, which is the height of the solid. Okay. So you can use this formula, capital B for area of the base times the height. You could even use that when you're working on a cylinder, because the area of the circle at the base is pi r squared, and then you go times the height. So what these notes are over here to the side is choose a formula for the area of the base. Basically, you have to look at it and decide what the shape of the base is and use an area formula for that shape. Find needed dimensions. So that's basically like what if there's a missing number that you have to figure out. And then those are formulas. And if the solid is oblique, use the height perpendicular to the base. We're not going to do any oblique ones, but an oblique one that looks like it's leaning. So maybe I can show you a picture of one of those another day, but I don't have any on these notes. So on this first example here with the triangle. Huh?
How about you Google one?
Oh, you want me to show you one? Okay. 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 So that's what it looks like. Leaning. And if you want to find the volume of it, you have to use the perpendicular height, not the slanted height. This figure here, this diagram is a really, ooh, goodness. This is a really good diagram because it's showing that the radius is the same. But you need to use this height here that's perpendicular if you get an oblique. Okay.
Yeah.
Okay. So on example 1 there, can you figure out which of the faces on that solid is the base? What is the shape of the base on that? On this one.
What?
Yeah, it's a triangle. So let me get my highlighter going. There's your base. So we need to find the area of that triangle because our volume formula is volume equals the area of the base times the height. So we need to find the area of that triangle. Now a formula for the area of the triangle would be This is the formula for an area of a triangle, right? 1/2 BH, little b, not capital B.
Why for AB?
Because, well, if you want me to, I can put an A, but capital B stands for the area of the base.
Oh.
So I can put an A here if you want. So we need to do 1/2 times, and then we need to figure out what is the base and height of that triangle. What did you say?
9.
Okay. And
9.7.
so you're seeing the 9 at the bottom, but do you remember that the base and the height have to be perpendicular to each other?
Yeah.
Well, this 9 doesn't have anything perpendicular to it, so we can't use that side. We have a perpendicular right angle mark right here for this line. So this is our height, 7.7, and it's perpendicular to this side. So this side is our base. So where's a number for this?
11.
Good. Okay, so we're going to do 1/2 times 11 times 7.7. Okay. Okay, I got 84.7, but I have to do half of that. So I'm going to go times 0.5. And I got 42.35. And that's inches squared. All right, so that's going to go inside of my volume formula in place of the B, because that is the area of the base. Now this height for the height of the whole solid. So how tall is the solid?
18.
Did you say 18?
Yeah.
Mm-mm. Are you like adding the 10 and the 8? Is that what you're doing?
Yeah.
No, they just want to know, okay, if it's sitting on this green triangle, how tall is it going to be? So this right here is how tall it's going to be. So it's 8.
8.
So now I have to do 42.35 times 8. $338.8 inches. Now, if we do inches squared times inches, what do we have? Good. Nice work. So this is our final answer. Now, when we do these problems, we have to be very careful because see how the area formula for the little triangle has a B and an H, but the volume formula also has a B and H. And these two B's and H's are not the same B and H. Very careful that we're understanding what's what.
We got a windmill. Volume capital B area locate B.
We have to remember volume is what?
Locate B area locate B.
I am struggling. I heard you say something about area.
Area locate B. We got to remember little B.
Little b?
Yeah.
Okay. I understand what you're saying. You're right. That's why they have some of the letters are capitals and some of them are lowercase. You're right. Okay, so now we're going to do a different shape. So now we have a rectangular prism. So capital B times the height of the solid. So capital B is going to be the area of, now which side do you want to make your base? It's all up to you. So you want to use the 9 for the side that has the base?
Yeah.
Okay, so then that makes this our base. Okay. That one and this one, these are our base. Because the prism always has two bases that are parallel. So what do we do to find the area of that green side?
9. 9. 9. 9.
Good. So we're going to put that number for the B. And we still need to get the height of the solid. So if it's sitting on this bottom, how tall is it? Exactly. So we're going to go, whoops. V equals 63 kilometers squared times 7 kilometers. So 63 times 7. 7 times 3 is 21. Put down 1, carry 2. 7 times 6 is 42. 42 and 2, 44. Okay.
Yeah. Yeah.
All right, let's do another one. Find the volume of the solid in terms of pi. So the circle is the base, right? So to get the area of the base, we need to do pi r squared for the circle, because that's the circle formula for area. And what is the radius of the circle?
Pi.
Good job. So now what does that become when I work it out?
Pi.
Good. So 25 pi inches squared for the area of the base. So that is going to go here for the B, right?
Yeah.
Just write it below. And then what is the height of the cylinder?
Wait.
Good. So now we just have to multiply 25 times 3.
And one.
Good. And pi. And inches cubed. Yes, good job. That was easy, wasn't it?
Yeah.
All right, we have one more example.
When will we do the fluid error?
When will we do what?
The fluid error.
Why am I not understanding the... Are you talking about a certain shape?
No. Do you got more fluid error? No.
Do I have more?
No, you got more fluid error? No.
I know most of what you're saying except that one word. Do I have more what?
No fluid error.
I think I need you to type it on the chat. Surface area. Oh, there's only one more surface area problem, and it's going to be
Going do it. Going do that one. Hello.
hello, sorry, but my mic stopped working. Okay, so no, I can't do the surface area one tonight because the spheres, I don't have the notes and stuff ready, and those are going to be a lot more work because there's different kinds of problems. So we need to do it on another day.
Monday.
So let's just do this one. Sorry. So here we go. We're going to do this as our base now. And I know it's not on the bottom, but it's still the base, because one thing you have to think of when you have a prism, the side that is the base is a side that if you could slice the solid in slices, all of the slices would have that same shape and size. So that is how you know that that trapezoid is the base. Because if you slice it in any other shape, they won't all be the same. But if you slice it into trapezoid slices, you know, like if you could slice it along this edge, you would just have a bunch of trapezoids, wouldn't you?
Yeah.
Yeah. So that's how you know trapezoid is your base. So we have to work out the area of the trapezoid and then multiply it times the height if it were sitting on top of this trapezoid. So let's think about that first. If it's sitting on top of this, then the height would be this side here, wouldn't it? That has a length of 16.
It's long.
Oh, shoot. Can you still hear what I'm saying?
Yeah.
Okay, so can you see my hand moving now?
No.
Oh, shoot. Okay, I'll hang up and try one more time.
No, I can.
Oh, now it's working?
Yeah.
Okay. So the height of the prism will just be this measurement here, which is the 16. But we have to find the area of the trapezoid. So the area of a trapezoid is this crazy long thing. Okay. So what are the two bases on the trapezoid? They're the parallel sides that are not angled looking. So the ones that are parallel are the ones that have these little arrows on them, right? So this and this, those are the bases. So one of them is marked a 5, but this one doesn't have a mark. What is the measure of this other base?
No.
Good. Nice work. So for B1 plus B2, I'm going to put 5 plus 9 over 2. And then the height is 16. Oh, just kidding. It's not 16. The height of the trapezoid. The height of the trapezoid is 4.6. So this is going to be 14 over 2. Good. Times 4.6. So what is 7 times 4, Connor?
Mom, you're right.
Good. And then 7 times 6 is 24. So 7 times 0.6 is, oh, sorry, no. 7 times 6 is 42. And 42 times, 42 has to have the decimal point popped in. So it'll be 4.2. Do you know what I mean? Because I'm doing 7 times 4 to get the 28. And then I'm doing 7 times the 0.6. And 7 times 0.6 is 4.2. So this is 32.2. And that is feet squared. And now we are going to put that here, but we need to know the height of the whole solid is 16. So the volume is going to be 32.2 for the area of the base times 16 feet for the height of the solid. So now I need to work 32.2 times 16.
No, you did wrong.
Oh, what did I do wrong?
1.9. Oh, point in the eye.
4.6 is the height on the trapezoid, but the height for the whole solid is 16.
Oh,
Okay.
I didn't know.
It's okay. I appreciate you trying to help me. So I got 515.2.
Me,
Good. All right, so let's look at some more. So we're going to do just 3 more. We're going to do 1 more triangular solid. And it's not going to be this one because that's on my notes. We're going to do this one. And then we're going to do this cylinder. And yep, we're going to do these 3 problems. So we're going to start with this. So what shape is the base of this solid? Good job, Connor. So for the area of that triangle, we have to do the triangle formula, which is 1/2 BH. So that's going to be 1/2 times, and then see how there's a right angle here? So that means there's another right angle there, right?
Yeah.
So remember that your base and your height on a triangle are perpendicular. So this 8 is also here. This 6 is also here. So it's 8 times 6, right? All right. What is half of 8?
I know. It's not it.
Well, but you don't have to do 8 times 6 because you have to take half. You could start by doing half of 8 and then take that answer times 6, and it will be easier.
More.
Yeah. So now 4 times 6 is
Oh, yeah.
24.
Oh, more.
4 times 7 is 28. 4 times 6 is 24. So this is going to be inches squared. So then when we get to do BH, we're going to do 24 inches squared for the area of our base. But what is the height of the solid? So what is this dimension that is kind of perpendicular to the base? If this is our base, what is perpendicular to that? It's this right here. You know, because if you sit this figure flat on top of this triangle, that will be how tall it is, right? It will be 3 inches tall.
Yeah.
Is that kind of hard to understand, or do you know what I mean?
I know what you mean.
Okay, good. Now we have to do 24 times 3. So let's go over to the side and multiply that. 3 times 4 is 12, so I'm going to put down 2 and carry 1. 3 times 2 is 6, and 1 is 7. So I have 72. Inches cubed. Okay? All right. Number 2 now. Oops, wrong way. So we're doing this cylinder. I kind of like how the cylinder is sideways because it makes you think. So the circle is still the base, even though the cylinder is laying on its side and not on its base. This circle is still the base. Because if I want to cut all the slices to be the same shape, I have to make them circular slices.
Yeah.
So what is the area of that circle? I have to do A equals pi r squared. So what is the radius on that circle? Good. Okay, so then that's going to be pi times 11 kilometers squared. Do you know what 11 times 11 is? Good job. So that's 121 pi kilometers squared. And that's just the area of the base. So when I go to do V equals BH, that's going to go in place of the capital B. What is the height of the solid?
Yeah.
Good work. So we have to do 121 times 6.
I might know it.
Oh, okay. Go ahead.
I don't know it.
That's okay. Look, I wrote it right here. So 6 times 1 is 6. 6 times 2 is 12. Put down 2, carry 1. 6 times 1 is 6, and 1 is 7. Good. So we have volume is 726, and we have to remember the pi kilometers cubed. Okay, last problem. This is a rectangular solid. So I'm just going to let this be the base. Rectangular prisms are kind of unique because you could let any side of a rectangular prism be the base. So what is the area of this base? Good job. Okay, so now I need to do the volume. So I'm going to replace the capital B with the area, which was 70 meters squared. And I need to go put the height there now. So what is the height of the solid? Good. So what is 7 times 7?
9.
So 7 times 70 is?
9.
No, you just need to put 1 0 on there.
Oh, 9.
Good.
Millkill.
Nice work, Connor. Okay, that was our last one. So let me go ahead and press stop on the recording. I know, I'm going to fix it. Okay, so we do not have to talk about everything that is here in this bell work, but this whole lesson is about spheres. And you know that a sphere is like a ball. So the most important question that is on this bell work that we have to talk about is this one right here, number 2. It says, which cross section came from the largest sphere? So you know a cross section is just a slice?
Yeah.
So if you could cut a bunch of slices out of a sphere, they would all be circles, wouldn't they?
Yeah.
But they would all be different sized circles.
Yeah.
So these could all come from the same sphere, couldn't they?
Yeah.
Because this one could be right in the middle. And this tiny little one, this could be close to the edge.
Yeah.
So that's one thing I wanted you to think about. Okay. Now let me grab these notes. So here you have some formulas. This is the surface area of a sphere formula, which says 4 pi r squared. And the best way to help you visualize that is to show you this little drawing down here. And it's really tiny, so it's hard to see, but anyway. You know what this is? This is the covering of a baseball. So if you undo the stitching on a baseball, this is what it looks like. So it's basically just 4 circles all put together.
Yeah.
And that's what this formula says, because it says 4 pi r squared. So that's 4 times the area of one circle.
Yeah.
So if you want the surface area of a sphere, it's going to be like 4 circles that cover the sphere, 4 pi r squared. Which seems really strange, but that's true. Now, this is your volume formula. This one is harder to understand. This one is 4/3 pi r cubed. Okay? So we're just going to use those formulas. Good. Okay. So let's look at example 1. It says find the surface area in terms of pi. So surface area is 4 pi r squared. Good. What is 4 squared? Okay, so we have to do 4 times 16. $64. Yep, that's right. Super easy, right? So the main thing we had to remember was that a radius is half of the diameter. And you did that like a pro, because they have one dotted line that is showing like a circular cross section, and then this red dotted line is showing the diameter. Okay, let's do example 2. Find this volume in terms of pi. So the volume formula is 4/3
Pi. Oh.
not squared.
Yeah.
Good. And the way I always remember it is area is squared, so the R is squared in the area formula. Volume has cube units, so the R is cubed in the volume formula. That's how I remember it. So what is the radius on that one?
No.
Did I lose? Yeah, 9. And we have to cube that. Oh goodness, that's going to be a big number. Well, goodness. I'm going to present my screen really quick because I want to show you how you could do that on a calculator because it has a fraction in it. Okay, so we have to do 4/3, right? So to get 4/3, you can do 4 divided by 3 equals, and there's your 4/3, 1.3 repeating. Now I'm not going to press the pi button because they said to keep our answer in terms of pi. But I do need to do 9 to the 3rd power, okay? So I'm just going to say times 9 times 9 times 9. There you go. Okay. And I'm going to write 972 kilometers to the 3rd power. Now there's another way I could do that. If I want to see the 9 being raised to the 3rd power, here I'm going to start it over and I'm clear. And I'm going to start with 9 to the 3rd power. So I'm going to press 9, and then I'm going to see this button that says x to the y power here. I'm going to press this, and then I'm going to say 3. And I'm going to give it equals. Now this is my 9 to the 3rd power, okay?
Yeah.
Now I'm going to say times 4 divided by 3 equals. Okay? Okay, so 972 is our answer.
And you make it bigger.
What do you want me to make bigger? The calculator?
No, make you clean. That way I can see you paper.
So it's not showing my paper anymore? That's weird. It's showing my paper. Huh. Well, maybe I'll just stop sharing the calculator then. Okay. So
Not well.
you can see it now, right? Okay, good.
That's what I meant.
I have to box the answer. Yeah, okay. So now let's do number 3. Find the surface area of a sphere with a circumference of 18 pi centimeters. Now they made this problem tough on us because they didn't give us a drawing at all, did they?
Yeah.
But you can't really label the circumference with a number very easily anyway, because the circumference is the edge. So then we just need to do this differently. Okay, so if the circumference has 18 pi centimeters, they must be talking about the circumference of what is called a great circle. So this dotted line here,
Yeah.
that's called a great circle. It's called that because it's going right through the center and it would slice the sphere into 2 equal parts. Okay. That must be the thing that they're saying has that 18 pi centimeters. So we're going to do circumference equals pi times diameter. And since we know that the circumference is 18 pi, we're going to put 18 pi in place of the circumference. We're going to substitute it for that. But we're just going to keep this pi d on the other side. So what can I do to solve for d?
Double.
What do you want me to divide by?
Pi.
Good. So then I have d equals, nice. Okay, and it was in centimeters, so I should have put that. Oops. Okay. No, it's not squared because that was a circumference, so that was just my diameter. So if my diameter is 18 centimeters, now I have something I can put on a drawing. So let me draw a circle, and I'll put a radius inside of there, and I'll put, well, I have the whole diameter is 18. So what is the radius?
9.
Good. So now I'm ready. I need to find the surface area. So SA equals 4 pi r squared equals 4 pi times 9 centimeters squared. What is 9 squared?
81.
Good. So I have to do 81 times 4. 81 times 4. So I have to do 4 times 1 is 4, and 4 times 8 is 32. That gives me 324 pi centimeters squared.
Yeah. It will be.
All right, we have one more problem to do. Find the volume of the given sphere in terms of pi. If you know that the surface area of the sphere is 64 pi centimeters squared. Okay, so we're going to take the surface area formula, and I'm just going to write directly beneath this. Surface area is 4 pi r squared. So if I know that the surface area is 64 pi, I'm going to replace the SA with 64 pi. Now what?
Find the way.
You what? Did you say calculator?
No. You gotta find the way.
Oh, the radius. Yes. So how do I get the radius by itself?
Divide.
Good. So I can divide by 4 pi. And these will cancel because that leaves it with just 1 r squared. Those cancel. 64 divided by 4 is 16. So that means r squared equals 16. Now what?
Well,
Very good. So the square root of 16 is what? Good, 4. So now we know the radius, but that's not what we were asked for. We were asked for the volume in terms of pi. So volume equals 4/3 pi r to the third. So this equals 4/3 pi,
9 more.
and it's centimeters to the third. So then I have to do the math. So I need to go get a calculator for that. Okay, so 4 to the third is 64. So now I have to do 4/3 times 64. So I'm going to go 4 times 64 divided by 3. It says this number, 85.3. So that's 85 1/3 because it's a 0.3 repeating. 85 1/3 pi. Okay. All right, so let's just take a look back at everything. The big idea is you have to be able to find your radius because all of the formulas use radius. And then sometimes it's simple because you just know the radius and you plug it into the formula. But sometimes they give you something like a circumference and you have to solve for the radius and then do the formula with the radius. Or they give you a surface area and you have to solve that for the radius and then use the formula, right?
Yeah.
Okay. So I want to remind you real quick about some vocab that we used tonight. A great circle is a circle that splits the sphere in half and it shares its center point with the circle. So this thing that I'm drawing a line over right now, that's a great circle for this sphere because it would split it right down the middle. And the circumference of a sphere is the circumference of its great circle.
Yeah.
So that was something we had to remember that. That was that one question that had circumference in it. So I just wanted to remind you about that. Okay, I'm going to go ahead and press stop on this recording. We did a good job.